We're now going to turn our attention to one of the most interesting operators that's defined in the Project Reactor's Flux class. And this, of course, is the subscribe terminal operator. A terminal operator, as the name suggests, terminates a stream, and it also triggers all the other operators that are processed in the stream. That's what makes a Flux stream lazy. Nothing really starts to do anything interesting until the terminal operator, like subscribe, is reached. So the terminal operator is used to subscribe a consumer to a particular Flux. And it takes 3 parameters in this overloaded version. There's other overloaded subscribe methods that take other numbers of parameters and other types and so on, but we'll just focus on this one first for reasons you'll see in a moment. The first parameter is a consumer, which is a Java 8 functional type, which is used to receive all the elements in the sequence that occur normally. These are the on-next signals, and so that comes in through the first parameter. The second parameter is also a consumer, and that's used to handle any error signal that may occur. And then the third parameter is a runnable, and that's used to react to the completion of the stream. So when the onComplete operator signal is called, then that goes ahead and causes the runnable to come through there. This particular subscribe method requests unbounded demand. In other words, it wants the publisher to send events as quickly as it deems possible, and it pledges to be able to handle that somehow. We'll see later that there's other subscribe methods that can be passed in, a subscription that can be used to exert flow control to prevent a fast publisher from overrunning the resources of slower consumer or consumers. The signals that are emitted via this method are represented by the following regular expression, which we've talked about before, but which will probably make a bit more sense now. So first and foremost, you can see that there are 0 or more on next signals that are sent. Those come through that first parameter. And then there can optionally be 1 on error or 1 on completion signal. On completion and on error are mutually exclusive. You only get one or the other, but you may get neither because they're both optional. And of course, for that matter, you could get either 0 on next events or an infinite number of them. So those are how the actual signals occur. And then we just saw how they're passed back to the appropriate parameters that we provided when we called the subscribe call. Subscribe returns something called a disposable, which is an indication that a task or a resource can be canceled and or disposed of. And this is useful for managing resources so that you don't leak resources indefinitely and then eventually run out of memory. You could actually use a very interesting class called a disposable composite in order to accumulate a bunch of disposables and then dispose of them in one fell swoop. So here's an example that we see where we go ahead and create a field of type disposable composite. Then we do some stuff. Then we go ahead and initialize that field to call disposables.composite, which is a factor method that takes a varargs number of handles or reference objects. In this case, we pass in a publisher scheduler, a subscriber scheduler, and a subscriber. And those things are then used for various purposes. Then we do some more processing. And when we're all done and we want to get rid of all these various handles or reference objects, we go ahead and call the dispose method on mDisposables, and it gets rid of them all in one fell swoop. When the subscribe operator is called, it will go ahead and initiate or trigger all the processing in the Flux stream or the chain up to that point. So as you see in this particular example, we're going to have a list of big fractions. We convert those into a Flux stream of big fractions using the from iterable factor method. We then go ahead and take each of those big fractions and we multiply them by an S big reduced fraction constant. And then the subscribe operator is called, and that will then trigger all the processing. And then of course, also register these various callbacks to handle the output. Let's take a closer look at the example here. We're going to look at this in more detail when we get to the case study at the end of the lesson, but just really quickly here, you can see the first parameter does the normal processing. These are the on next signals. And what it does is when the next big fraction gets emitted, it just goes ahead and it appends it to the end of the string builder, SB, after converting it to a mixed string. If for some reason an error were to occur, then it will go ahead and append the string error to the string builder and do some stuff to clean up. And then finally, if an on completion event or signal should occur, then what it'll do in that case is it will go ahead and call the display method on our big fraction utils class, which tells it to convert the string builder to a string and then display it. So that's kind of like handling the end of the stream processing at that point. Calling the subscribe method will typically not block the caller thread. Now, this is a little bit subtle. If you only have synchronous operations, then subscribe may not return until all the processing is done. But most normally, we use subscribe with asynchronous operations, and we'll talk a lot more about those later, using various concurrency operators like subscribe on or publish on. So if that's the case, then for these async streams, the subscribe method will return right away, and then the processing will actually continue running in the background until the upstream terminates normally or an error occurs. So you have to be prepared for the case where subscribe returns right away. And that semantic motivates the need for something like our async task barrier framework, which we'll talk about and show many times to illustrate how you can wait for all the processing to be done before you actually return control back to the main thread that's waiting for all the other asynchronous operations to complete. There's a number of different subscribe operator methods. They're overloaded methods. Here's another variant. This one takes a fourth parameter, which is a consumer that's parameterized by a subscription. So it's a subscription consumer. And you can use this to pass in a custom consumer that will be called back when the initial subscribe signal occurs when you connect to the publisher. And then this particular subscription consumer can be used to apply back pressure to say, don't send more than n events or n signals at a time. And then it can also be used for other features that we'll talk about in later lessons in this particular part of the course. RX Java has a subscribe method as part of its observable class, and it works very similarly to the Project Reactor. Flux subscribe, there's a few subtle differences because the observable class was implemented before some of the later stuff came with the specification for reactive streams. So there's a few subtle differences, but it's very, very similar in a lot of ways. So that's the end of our discussion of the subscribe terminal operator. Very useful operator to know about, very useful operator to learn how to apply properly in practice. And you'll see it gets applied in a number of the examples that we're going to cover as we go through the rest of the course on Project Reactor features.